Hello everybody. Welcome to another in our series of looks at contest problems or types of problems that you might see on a math contest. This is actually taken from another YouTube channel called Mind Your Decisions. Really excellent content by Presh Telwalker. And he gives a solution to the following equation. Cube root of x plus the cube root of x minus 16 is equal to the cube root of x minus 8. And of course, the goal is to solve for x. And I want to give just a slight variation of the proof that he gave in his video. If you want to watch his video, there'll be a link in the comments. What I want to do, though, is utilize some very subtly hidden symmetry. Subtly in the sense that it's not that hard to find. So you'll see here we have these three numbers under the radicals, x minus 8, and x minus 16. Of course, the smallest is x minus 16, right? If we put these on a number line, there'd be x minus 16, here'd be x minus 8, and here would be x. And of course, the distance is going to be 8 in between these numbers. So this actually suggests we could do a substitution to center everything around x minus 8 rather than using the x here. So if we make the substitution u equals x minus 8, we do this number line again, then the middle term becomes u, and then x is 8 more than u, so this is u plus 8, and x minus 16 is 8 less than u, so this will be u minus 8. Okay. So we can rewrite the equation that we're looking for as the cube root of u. Let's see, what was it? It was x. So the cube root of u plus 8. And then the cube root of, let's see, x minus 16, that became now u minus 8. And on the right-hand side, we just have the cube root of u. Okay. Now, again, I don't really like to play around with cube roots. They're a little bit annoying. So I'm going to give this just the name A, and this the name B, and this the name C. So I can simplify my life and just write, oh, A plus B is equal to C. I also know that if I cube A, I get U plus 8. If I cube B, I get U minus 8. And if I cube C, I just get U. And looking at it this way, I see already some patterns emerging. For example, if I add A cubed and B cubed together, the 8 and the negative 8 are going to go away. Right? So A cubed plus B cubed, that's going to equal 2u's, and then the 8 and the minus 8 go away. And 2u, wait a second, that's just 2 times C cubed. All right, so I immediately have a nice relation. Okay, but A cubed plus B cubed, that's a standard setup, right? In algebra, I can factor this. Okay, so let's do that over here. So I know that 2C cubed is A cubed plus B cubed, but that's the same thing as A plus B times A squared minus AB plus B squared. Okay. If you don't believe it, of course, you can distribute this. You could also draw a geometric picture of this. Like it's not hard to verify, but this is definitely a formula. If you're going into a contest, you want to know this factorization. But now A plus B, hey, that's equal to C. So this is C times. All right. Well, this next bit, this almost looks like a square, right? If you had maybe a minus b squared, except this doesn't have the 2ab. But you know what? I don't even want a minus b because I don't know about that, but I do know about a plus b. So what if I wrote this in terms of a plus b squared? So this is a plus b squared. And then, well, let's see, if I distributed, I'd get a squared, I'd get a b squared, but I'd also get 2ab. I don't want 2ab, I want minus ab. Okay, fine, I have to subtract 3ab. Okay, fine. Now, at this point, I would like to divide by c. The only reason I can't do that is if c is equal to 0. Let's look at that case separately, right? What would it mean if c was equal to 0? Well, if c is equal to 0, then that means that c cubed is equal to 0. And c cubed is u. So u would equal c cubed, and that would equal 0. Okay, what was u? Right, u, we define this as x minus 8. So this would imply, actually, we could just do it from here, right? So if u is equal to 0, what happens? I would get the cube root of 0, I would get the cube root of 8, and I would get the cube root of minus 8. Hey, wait a second. Cube root of 8, that's 2. Cube root of minus 8, that's minus 2. 2 plus minus 2, that is equal to 0. So we actually found a solution, right, when we were trying to avoid a solution, right, somehow, right? We were trying to avoid c equaling 0, but that actually is a solution. Okay, so we found one solution already, right? So, and that's when u is 0. Of course, u was equal to x minus 8. So that means that x is equal to 8, right, is a solution. Okay, so let's ignore that solution for now then, right? So we're going to assume now that c is not equal to 0. So in that case, I can divide by c, and I get 2c squared is equal to, okay, this c goes away, and now I have a plus b quantity squared, but again, a plus b is equal to c. So I get c squared minus 3ab. All right, well, of course, I can drop one of these c squareds, and I get c squared is equal to negative 3ab. Okay, that's not wonderful, but hey, we've gotten somewhere. Now, the reason why it doesn't feel wonderful is because a and b, I know ultimately are these cube roots. I don't want those cube roots. So I want to rewrite everything in terms of a cubes and b cubes, so that's much easier. Okay, well, let's just raise everything to the third power. So I get c to the sixth is equal to negative 27 a cubed times b cubed. But a cubed times b cubed, that's just me multiplying u plus 8 with u minus 8. So this is negative 27 u squared minus 64, right? It's just the difference of squares formula. What about the other side? Well, c cubed is u, so c to the sixth is u squared. I just have a quadratic now. Let's see. I'm going to get negative 27u squareds on the right and 1u squared on the left. So this is 28u squareds, right? If I just move these over, is equal to, well, negative 27 times 64. Negative 64. So in fact, this minus goes away. Okay, I could distribute, but I don't want to because I'm going to now divide by 28 and take a square root. So I get u squared is 27 by 64 over 28, which, okay, let's see, simplify. 64 over 28, that's 32 over 14, that's 16 over 7. Okay, so 27 times 16 over 7. And now u is going to be plus or minus the square root of 27 by 16 over 7. And we can simplify that a little bit. Let's see, 27 is 9 times 3. 9 is a square. And 16 is a square, yeah? So let's see, if I pull out the 9 from the square root, I get a 3. If I pull out the 16, that gives me a 4. 3 times 4 is 12. And then I'm left with root 3 over 7. All right, so I've just found my solutions for u. Of course, I wanted my solutions for x. And you remember u was equal to x minus 8. So that tells me that x is equal to u plus 8. And so what are my other two solutions? Well, if u is plus or minus 12 root 3/7, so the other two solutions are x equals 8 plus or minus 12 root 3/7. Right? So we end up with three solutions. X equals 8, and then x equals 8 plus or minus 12 times the square root of 3/7. All right. So, depending on your point of view, this is either going to be much easier than what Presh did in his video or much harder than what Presh did in his video. The point isn't to decide who's right, who's wrong. I mean, we're all right, right? Like we're getting correct solutions. It's a matter of points of view, right? Sometimes one solution path is going to be easier for you to spot than it'll be for me to spot, and vice versa. Okay, so here's just another way of approaching this, and what I like about it, right, is utilizing the symmetry. All right, that symmetry actually makes some things a little bit easier for me anyway.